The magnitude of the vector is the square root of ax squared plus ay squared plus a of z squared. And so we can take a simple example. For instance, I take a vector A. So this is just an example to see this in action. And we call A 3x roof. So A of x is 3 minus 5y roof plus 6z roof. So that means that it's 3 units in this direction. It is 5 units in this direction, in the minus y direction, and 6 in the plus z direction. That makes up a vector, and I call that vector A. What is the magnitude of that vector, which I always write down with vertical bars? If I put 2 bars on one side, that's always the magnitude. Or sometimes I simply leave the arrow off. But to be always on the safe side, I like this idea that you know it's really the magnitude. It becomes a scalar when you do that. So that would be the square root of 3 squared is 9, 5 squared is 25, 6 squared is 36. So that's the square root of 70. And suppose I asked you, what is theta? It's uniquely determined, of course. This vector is uniquely determined in 3-dimensional space. So you should be able to find phi and theta. Well, the cosine of theta, see this angle here, 90 degrees, projection. So the cosine of theta is a of z divided by a itself. So the cosine of theta equals a of z divided by a itself, which in our case would be 6 divided by the square root of 70. And you can do phi. It's just simply a matter of manipulating some numbers.